Okay, one more. Let's do part C. Y equals 2 to the x plus 1 minus 3. So let me shrink this down a little bit. So now making another table, x, and then y equals whatever I said it was, 2 to the x plus 1 minus 3. All right, I'm going to not necessarily plug in the same values. A good plan, when we end up adding something to the x value, in this case in the exponent, a good plan is to see what input would make that quantity involving the x 0. In other words, what input value would make the exponent 0 here? So -1, instead of centering the points we plot around the input of 0, let's center the points we plot around the input of -1, because that creates the 0 in the exponent. And then you get a nice selection of points if you do it that way. That's the only reason. So I'll go a couple to the left, a couple values to the left of -1. So I'll plug in like -2 and -3, and a couple of values to the right of -1. Speaking on the number line, obviously on this chart it's below it. So what would that be? 0 and +1. And then let's see what we get. Let's start with 0 and the positive value. Or let's start with -1, 0, and 1, and then we'll handle the negatives in a second. So what am I going to get for y if I plug in -1 for x, right? Yeah, well, you end up with a 0 in the exponent as kind of by design, right? And then you get 2 to the 0. Does everybody see that? That's what the exponent is when you plug in -1, right? And then 2 to the 0 is really what? 1 minus 3 is -2. Okay? What happens when you plug in 0? What do you get when you plug in 0? What does the exponent end up being when you plug in 0 for x? So 2 to the 1, and then we still have the -3 there, right? So what do you get there? 2 to the 1 is 2, right? -3 is what? -1. So 0, -1 is the point on the graph. And then when we plug in 1, what do we get for the exponent when we plug in 1 right there? 2 to the x plus 1, or 2 to the 2, right? So 2 squared minus 3, what is that going to equal? 4 minus 3, which is 1, right? So just plugging and chugging away at these things. Now it gets a little trickier when you plug in -2. So, okay, you plug in -2 there. What does the exponent end up being? So the exponent ends up being so 2 to the -1. Let me erase that. So you end up with y equals 2 to the -1 when you plug in -2 in for x. And then you still have the -3 on the end, don't you? So yeah, 2 to the -1 is 1/2. -3, what is that? -2 and 1/2, right? That would be a good way to write it. And then if you plug in -3, what do you get for the exponent on the 2 if you plug in -3? 2 to the -2 -3, right? And what is 2 to the -2? So yeah, 1 over 2 squared, which is 1, not negative, but 1 over 2 squared, which is 1/4. -3, which would be -2 and 3/4, right? Let's plot these points, and by the way, you should always think about where the asymptote go, right? Because obviously there's a few negative values, at least there's certain kinds of negative values allowed here. So we plot these values. Okay, at 0, I'm at -1. Let me do this one in blue. At 0, I'm at -1. So I plotted this one first. And then 1, 1. Yeah, 1, 1. So right there. And then what? -1, -2. negative 2, negative 2.5. Oops, went down a little too far. Negative 2, negative 2.5. And then at negative 3, I'm at negative 2 3/4. Right around there someplace. So where did the asymptote go?
Went down.
It shifted down. How many? It went down the distance you subtracted off from the exponential function, right? 2 to the x plus 1 is an exponential function. It's a shifted version of 2 to the x because you added 1 to the x in the exponent, but it's the minus 3 on the outside of the exponential function that shifts the entire graph down. And so it's going to shift the asymptote down with it. So when you draw this graph, you should draw it so that it doesn't cross the line at a height of negative 3. So in fact, I want you to even put that asymptote in as maybe a dotted line. So what's the equation of this dotted line? Y equals negative 3 is the asymptote for the graph in part C, for the equation in part C. And then when you connect the dots, just draw it so it doesn't cross that asymptote. Now, it should be the same shape as the other graphs. It's just kind of shifted around a bit. So like that. So by the way, if it were plus 5 instead of minus 3, where do you think the asymptote would be? If it were plus 5 on the end. It would be at a height of 5, right? You'll look at more relationships like that in your next class. All you really need to be good at here is plotting points